Hey guys, welcome to today's lesson. Today we are looking at the normal distribution using your GDC. This is primarily for the IB, AI and AA course. Okay, so first of all, I'm going to look at normal distribution, about what it is, and then obviously how to apply that to the calculator. So first of all, how do we know that we get a normal distribution question? Well, it should say normally distributed within the actual question itself. Now, when I see that, this is the first thing I'm thinking about. Okay, I'm thinking about that kind of bell curve where we had the mean in the middle. Okay, and then understanding that what the distribution talks about are these percentages. Now, we say that within 1 standard deviation of the mean, that's either side, we have approximately 68%, so 68% of all of our data. So 68% of the cohort should score between 1 and -1 z-scores, or 1 standard deviation between the mean. If we want to look at 2 standard deviations from the mean, either side, we extend that to 95% of all scores, which is almost the whole population. Now, if I kind of make these a little bit smaller, we get 34%, 34%, that's for the 1 standard deviation, and then we get 13.5% and 13.5% as such. If we then extend that again to 3 standard deviations, which is now going through almost my whole population, so that's -3 and +3 on the z-scores, we're going to be talking about 99.7% of our population, which would be 2.35 and 2.35. Now, if we are 99.7%, that means we get 0.3% either side, which is 0.15% if we halve it like that. Now, that's something that we have done previously when we're looking at the normal distribution. Now, if you're getting questions such as, we give a mean of, let's say, 50, we have a standard deviation of 10. That means I'm going to put a 50 in the middle. I'm going to then put 60, 70, and 80, and likewise 40, 30, and 20. Now, I could get a question such as, what's the probability that I get a score that is greater than, let's say, 80? A score that's greater than 80. So all I need to look at, there's where 80 is. That's 3 standard deviations above the mean. We can see it's 0.15%. That's a really nice, easy probability to do. They might say, what's the probability that I get a 70 or above? Well, now I'm going to add in the 2.35 on top of the 0.15, and now I'm going to get 2.5%. Okay, those probabilities are really easy. The problem is we're going to get questions where it's going to say a score of 75, for example. Now, a score of 75 sits in between 70 and 80. Now, we can kind of estimate it, I guess, and say, well, we've got 0.15% and around about half of 2.35. The problem is, because it's a curve, it's not exactly a half, so it's not going to be accurate. And we're all about accuracy, as we know. So this is where our calculator will come into play. Now, your calculator mode, as you can see here on the screen, we are looking at the statistics mode. We're looking at distribution, of course, and we're looking at normal distribution. When you choose that screen of normal distribution, we're going to have these 3 options. Okay, we're going to have the NPD, the NCD, and the inverse norm. That's really important for us. So the NPD, the NCD, and the inverse norm. Now, if you're looking for a probability, so you're trying to calculate the probability like we were just doing those previous kind of examples, we're using the NPD and the NCD. The main difference, of course, the NPD, that's when we're finding a particular score. So it's one given score. So for example, I could have said there, what is a probability that I get a score of 75? Whack my 75 in, whack my mean in, whack my standard deviation in, execute it. If I am asking those questions about 75 or above, that means I've now got a range of scores, and that's where the NCD comes in, okay, for that range of scores, that cumulative. Okay, now, what we're looking for is the inverse norm, is when we are given the probability. So we are given the probability, and we're actually finding a particular score, all right? We're finding a particular score. So it's that kind of reversal type of question. And this is what it's going to look like, right? You know, these are the three options. This is my NPD, this is my NCD, and this is going to be my inverse normal distribution. So you can see here, all of them have the same functions of standard deviation and the mean. In this case, it's the population mean, mu. The only real difference is, for the NPD, like I said, you only have one score. For NCD, you have the range of scores, the lower and the upper. And of course, the inverse norm, you're looking at the area because that's the probability. So you're given the probability, we're going to reverse that to find one of the scores. And of course, we are asked to find the tail, whether it's left or right, and we'll explain that when we get to it. So I think the best way to look at this, gents, is to look at an example. First of all, this example says a forest has a large number of tall trees. The heights are normally distributed. As I said to you before, you're going to be told that it's normal distribution. It will be in the question. The minute I see that, I'm thinking, okay, am I going to be doing NCD, NPD, or inverse norm? We need to look for some more information. The next thing I look for is, do I have the mean? Yes, I have the mean of 53, and I have the standard deviation of 8. So let's write that down. We have the mean of 53. We have the standard deviation of 8. Perfect. We know we need that no matter what case we are using. It then said that trees are classified as giants if they are more than 60. And it's asking us to find the probability that it is a giant. So what we're looking for is a probability that my score, let's call my score X, is greater than, in this case, 60. Which basically means we have a range. Okay, this lowest score that I want is to be 60. The highest score, or the upper, is going to be the highest possible score. Now, thinking about my normal distribution, if I've got my mean there of 53 and 60 sort of sits in that range there, and I'm looking for that shaded part on the right hand side, well, realistically, you're not probably going to have many scores above 70 or 80, but this is what I do. I always put my upper as 10,000. You're probably okay to put it as 1,000, to be honest, but I put it as a really big number, so I definitely know it can't involve anything more than that. Okay, they're very, very unlikely. So what I'm going to do here, I'm going to go on my calculator to NCD because I have a range. So this is going to be NCD. I can see here that I'm going to press variable. I don't have a list of numbers there, so I'm going to press my variable. Now I'm going to go into my lower. We've said the lower was 60. We're going to put the upper as 10,000. You can put anything there if you want. You can put 1,000. You can probably put 100,000 if you want. My standard deviation, I've already said there, is going to be 8. And my mean, of course, is 53 for this example. I'm now going to go down. I'm going to hit the execute button. And again, we get a probability, in this instance, of 0.190789695. Or P equals 0.191 sig figs. Of course, you could put this as 19.1% if you would prefer. Pretty straightforward. You just got to figure out NCD, NPD, or is it inverse norm? Let's go to another question. A random variable X is distributed normally. There we go. That's the key. Normal distribution, NCD, NPD, inverse norm. That's the first thing I'm thinking about. With a mean, I'm going to write that down, a mean of 20 and a standard deviation of 4. On the diagram, shade the region representing a probability that is less than 25. So the first thing I'm going to do is I'm going to put my mean there. That's 20. I'm going to put the score of 25 on here, which is there, and it's asking me to shade less than 25. So it's going to be that left-hand side tail. Okay, that's the probability that I'm kind of looking at in this instance. It hasn't asked me to find the probability in this case, it just asked me to find the shaded region, which I've done. Part 2 now asks me to find the probability. It's a very similar question to the one before. Okay, so we know that my lowest score, because it says less than 25, now that could be anything. Think about these scores here. It could keep on going. Now, I could probably put 0. 0 is probably going to be the best bet because I'm not going to get less than 0 most likely. However, I don't really know what these numbers are. I mean, it could be temperature, and you can get less than 0 for temperature. So I'm just going to put minus 10,000 anyway. Okay, but again, if you put 0, odds are you're going to be okay. My upper. Now, I don't want this score to be more than 25. So I want to be 25 or equal to 25 or less. So I can put 25 there. If it's just less than 25, there's no rule change. Okay. And then, of course, I'm going to get that information. We're going to whack into the calculator. So I'm going to go back to my menu. We're going to get statistics. I think I'm in that zone already. So I'm going to have to go back out of that. We're going to go distribution. We're going to go normal. We're going NCD again. Variable there. I'm going to put my negative 10,000. Okay, I'm going to put my, we had 25, didn't we, as my maximum. Okay, my standard deviation, of course, was 4, and then my mean was 20. And then I'm going to execute that. And hopefully that should give us a good answer. And we get a probability, in this case, of 0.8943522. Okay, and to 3 sig figs, 0.894 would be correct, or you could put 89.4%. Either way, that's my probability. The next part of the question, of course, is where it gets a little bit more challenging, because what they do, they give you the probability. In this instance, we're looking at that inverse, okay, because we're given the probability. So I know that inverse normal is what we're looking at. So on my calculator, I'm going to exit back out of that. I'm going to go distribution. We're going to go to normal distribution again, but I'm going to press inverse. Now, in this case, I'm going to go down to the area. The area is the probability beneath that curve. Now, for example, if I wanted to do this and actually draw it out, this is what I'm going to have. This is my normal curve. We know that my mean is sitting inside here. We know 50% is that left-hand side of the mean. So 70% is going to be around about here, whatever score that's going to be, right? And so this is 0.7. I'm going to do it in green. I'm going to shade it. Okay. So what we're now looking at is my area is 0.7 or 70%. So I'm going to whack that in there. Okay. I'm going to go back up to make sure that my tail is on the left-hand side, because you can see where I've shaded this in green. That's the left-hand side of my graph, so I'm going to do that in green. My standard deviation and mean is already there from the previous question. So all I have to do now is press execute, and we now get this answer. It says C, so let's put C there. C equals 22.0976021. C equals 22.123 significant figures. And that makes sense. If I go back up to the previous diagram, 22.1 would be going somewhere around about there. We know that that shade region, the previous question was 89.4%. We're looking at 70%. So that means that this bit here is 70%. And that makes sense, right? So again, just to recap what we're looking at here. These three modes, of course, are what we're looking for. The minute you see the question that says normal distribution, think about statistics, think about norm, think about distribution, and then think about norm. Once you get to norm, you have your three options. Your NPD, that's for one score that you're looking for. So probably getting at 25. NCD is when you have a range, so less than 25 or greater than or equal to 25. And then the inverse norm is where they give you the probability, where you're going to reverse that process to go and find out what the score was. Pretty much that covers you for all of normal distribution. Any questions, please shoot. Apart from that, have a wonderful day.